In this video, I'm going to talk about lipids, which is another type of biological molecule. There's three major categories of lipids. We've got the neutral fats, which includes your oils, your fats, and adipose tissue. Phospholipids, which form the cell membranes, and steroids. So before we get into those three different kinds of lipids, let's just review something that we talked about in the carbohydrate video, which is that these four major types of biological molecules we're looking at, the lipids, the carbohydrates, the nucleic acids, and the proteins, are made. These categories of molecules are formed of monomers, and the monomers join together to make larger molecules called polymers. So it's like the monomers are the building blocks for the polymers. And in that carbohydrate video, I talked about two different kinds of reactions. The first reaction is where water is added to the polymer and the polymer breaks down into the monomers. And this is an example of hydrolysis. Right. Hydro referring to the water, and lysis means splitting or breaking. So that's how the polymer breaks down into its building blocks. The opposite of hydrolysis then, if the arrow was going this way and we were going from individual monomers into polymers, that was our, well, there's two words for it. There's condensation synthesis. Condensation synthesis or dehydration reaction. Right, and dehydration, because if we were going this way, well, water is being removed from the unit molecules and ends up as a product. Okay, and this diagram here, this is off of an old provincial exam asking you what molecule X would be. Well, if this is our polymer down here being broken up into the monomers, that would be hydrolysis, so molecule X would be water. Water added, and then as the monomers react to make polymers, water is released. So some general functions of lipids. They store energy. This is more like long-term energy storage, whereas carbohydrates was immediate energy. We also have lipids in the plasma membrane, as you know. These would be the phospholipids. And lipids are also components of steroid hormones, things like testosterone and estrogen. Okay, lipids do not dissolve in water, and they are electrically neutral. So because they don't dissolve in water, how do they get around? They get around in the plasma of your blood, which is water, and they have to get around in the fluid between your cells. And they do that with these transport molecules called lipoproteins. Okay, lipo refers to the lipid part, and they're proteins. And these what transport the lipids around. And we'll come back to this a little bit later. So the first category of the neutral fats includes fats that you're familiar with, like butter. These are usually solids at room temperatures, and they usually come from animals. Oils, on the other hand, usually come from plants, and usually a liquid at room temperature. And we'll talk about why that is in just a little bit. So functions of fats: long-term energy storage, as we mentioned, insulation, and protection of major organs. Now here again is how a fat molecule is formed. It's a dehydration reaction again. This time we have the building blocks are glycerol and then 3 fatty acid chains. You know, these 3 fatty acid chains, they can vary in length, so in the number of carbons that can change. Sometimes the carbons are double bonded to each other, and sometimes they're single bonded. If they are double bonded to each other, then we would say it is unsaturated. So you've probably heard those terms before, saturated fats and unsaturated fats. If it's saturated, it means saturated with hydrogen, which means the carbons are bonded to as many hydrogens as they can, which means that the carbons are singly bonded to each other. So this would be saturated, and this one is saturated, and this one is unsaturated because of the double bond. Okay, so when the glycerol bonds with the fatty acids, the hydrogen and the OH group also form a bond, making H2O, which is why we get 3 H2Os for every fat molecule formed. So if you've ever had to do the dishes, I'm sure you have, and you put soap into a greasy pan and you see all the oil separate out into little droplets, that's because soap is something called an emulsifier. An emulsifier has a polar end and a non-polar end, and it works to break down the fat into smaller pieces. It's not digesting it or just like destroying the fat, it's just making it into smaller pieces. Example of where this happens in your body would be bile. Bile is produced in your liver and released into your small intestine, and it breaks down larger fat chunks into smaller pieces, which then be digested by enzymes. And while we're at it, if you had to come up with the name of an enzyme that digests lipids, you might want to call it lipase, as you know that if it ends in A's, it's an enzyme. So bile and lipase are two different things, just to make that clear. Bile is a secretion which just emulsifies the fat. It doesn't actually digest it. Lipase actually works to break it down and digest it. Okay, so fatty acids are those hydrocarbon chains that we saw before, ending with COOH. And as I mentioned before, so if we say it's saturated fatty acid, that means no double bonds between the carbon. Unsaturated means that there are double bonds between the carbon atoms. And that affects whether or not it would be a solid or a liquid at room temperature. Saturated fatty acids tend to be solids at room temperature. So things like butter and cheese have a lot of saturated fatty acids in them. So here again, saturated versus unsaturated. So you've probably heard that saturated fats are not good for you, and while most studies definitely support this, it's not too hard to find a study or two that doesn't show any connection between saturated fats and poor health. But the majority of experts, and I'm definitely not an expert, but the majority of experts say that eating a diet high in saturated fats can raise bad cholesterol. So there is such a thing as good cholesterol. Bad cholesterol, or LDL, this is in reference to the lipoproteins. So remember I said lipoproteins are what transport the lipids around. So LDL refers to low density lipoproteins. Okay, and raising those has been associated with heart disease and atherosclerosis, and some other things we'll talk about more when we get to our unit on the cardiovascular system. Okay. But LDL, we want to keep that level down in our blood, and eating too much saturated fat can cause it to rise. So here's nutritional information on some Baby Bell cheese. So you see saturated fat, 6 grams, 4 grams of that is saturated. And then trans fat, well, we'll talk about that in class. That's also quite bad for you. So the second category of lipids would be the phospholipids, which you're familiar with from our cell membrane unit. The difference with the phospholipids is that instead of 3 fatty acid chains, there's only 2 fatty acid chains. One of them has been substituted with a phosphate group, hence the term phospholipids. So here's a image of a phospholipid. So here's the 2 fatty acid chains coming down. Here's the glycerol right in here. And then instead of that 3rd fatty acid chain coming down, we have a phosphate group attached. Okay, and you know about the significance of that phosphate group. It makes the head polar, which is hydrophilic, and all that good stuff we talked about when we talked about the cell membrane. The third and final category of lipids are the steroids. So steroids is a type of hormone. So some hormones are proteins, and some hormones are steroids. Examples of steroid hormones would be cholesterol, testosterone, and estrogen. So you remember cholesterol. Also, it's something that when you hear the word cholesterol, you might think, oh, it's bad for you, and it is bad to have too much cholesterol in your diet. However, you might also recall that it's part of our cell membrane. We have cholesterol embedded in the membrane, which helps regulate the fluidity of the membrane. So cholesterol is good for us to an extent. Testosterone and estrogen are responsible for the secondary sex characteristics of men and women, among other things. And so they look like this. They have 4 rings, right? And these are carbon rings. So if you see an organic molecule drawn like this, these points you can assume these are carbons. Okay, and unless it tells you otherwise, you can assume that they are saturated with hydrogens. So if this is a carbon right here, it's going to have a bond to this carbon, and it's going to have a bond down to this carbon, which means that it's going to have a hydrogen there and a hydrogen there, because carbon always forms 4 bonds. Okay, but we just save time and we just draw these shapes, and any organic chemist knows that these points represent carbon atoms.